Lesson 5, Loops, Explore. At the conclusion of this, you will be able to use appropriate vocabulary to describe loops, identify the exit point of a loop, trace a simple program with a loop. Now, you and your partner, or if we're doing this virtually, just you, need to have a game board, game pieces, tokens, markers, etc. to use as barriers and a robot. You can actually use anything. There is a game board available online that you can print off, or you can just take a piece of paper and give yourself 1, 2, 3, 4, 5, a 5x5 grid. You can use a few coins as your barriers and a paper clip or something that has an arrow on it as your robot. You have to know which direction your robot is facing. So if you don't have these items, pause and go get them. The paper that you can print out actually has these that you could simply cut out. Okay, now let's take a look. You have one command, move forward. This command moves the robot one space forward in the direction that it is facing. First, write the program to move the robot to the purple box. So your robot's here, you want to move it here. Pause the video and write the program. Does your program look like this? Move forward, move forward, move forward, move forward. Boom, yay. It's successful. Okay? You've moved forward 4 times and you're now in the purple box. Okay, well, this code that we wrote, or that you wrote, is kind of repetitive, and we would really like to be able to simplify it. So we're going to introduce the while loop. Now, here's how it works. While something is true, the code in the while loop runs over and over until the thing is no longer true. Let's try it. So here, var steps is set to 0. While steps is less than 4, we're going to move forward. And then steps plus plus. Plus plus means increment by 1. So what you need to be able to do is follow along with this program on your own game board. Now, you can't click. I have to click. So we start out, and one of the things that you're also going to need is kind of a scrap piece of paper so that you can keep track of, steps. So step starts out as 0. Is steps less than 4? Yes. Move forward says I need to take this guy and move him forward. Then steps plus plus says change this, add 1 to it. Now I'm at the end of the while loop, so I come back up here and I check again. Is steps less than 4? Yes, it is. So I will move forward. And then steps, I add 1 to it, so I get 2. I come back up to the top. Is 2 less than 4? Yes, it is. And so I move forward. And then I add 1, and I'm up to 3. Steps plus plus. That was where I added 3. Now is 3 less than 4? Yes, it is. So I move myself forward 1 more, and then steps plus plus. This becomes 4. Is steps less than 4? No, it's not. So what happens here is, since it's now false, I jump out of the loop. Okay? If you need to, rewind and go back through this. Okay, let's try this. Oops. Run this program on your board and see what happens. So pause the video and try this on your board. Let's take a look. While steps is less than 4, we move forward. So steps is 0, so you're going to move forward. While steps is less than 0, it's still 4. I'm going to move forward. And then I'm going to move forward. And then I'm going to move forward. And then I'm going to, whoa, I'm going to move forward. Why does the robot run off the board? Steps never changed from 0. Steps stayed 0 forever. Okay, this is what we call an infinite loop. The condition, steps, never changed. So if steps never changes within the loop, then it's never going to go from true to false, and therefore you can get caught inside the loop forever. It's like a Hotel California. You check in, but you never check out. Now, let's try this. You're going to get a new command, turn right. This command turns the robot 90 degrees to the right. Run the program on your board and see where the robot ends up. Okay, so pause the video and try it. All right, let's try this. While steps is less than 0, which it is, I'm going to move forward. Ding, ding, ding. There we go. And I'm going to turn right. Well, it wouldn't let me do that here. Then steps is going to become, oops, I've got steps. Steps was 0. Now steps is 1. And it's going to move forward. And then it's going to turn right. And I don't know why I can't do this. Okay. All right, hang on. I'm just going to pause a second so I can get something so I can turn it. Okay, now I fixed it so that it would work. So when it's 0, steps is 0, this is going to move forward and turn right. So I'm going to wind up here, move forward and turn right. Then steps becomes 1. 1 is less than 4, so this is going to move forward and turn right. So it's going to wind up here. Then steps will wind up being 2. 2 is still less than 4, so it's going to, so this will move forward and then turn right. So he's going to wind up here. Steps will increment to 3. 3 is less than 4, so it's going to move forward and turn right. Steps will be incremented to 4. 4 is not less than 4, so it will jump out. So I wind up right back where I started. Basically went in a circle. Okay, a while loop. There are 3 parts to it. First, you have a counting variable set to some initial value. Then you have a Boolean expression which checks the condition of that variable. Then you have a statement somewhere within the loop that increases or decreases the variable that is being checked. Note, if this piece is missing, you may create an infinite loop that never stops running, or could crash your browser. A for loop combines these 3 parts into one statement. Notice, var steps is set to 0, var I is set to 0. And you could change this to steps if you didn't want I. While steps is less than 4, I don't have to put while, I just put I less than 4. And then notice the steps plus plus, here's your I plus plus. It's all in one convenient statement. And then you just have to move forward. A loop is an example of iteration, a repetitive portion of an algorithm which repeats a specified number of times or until a given condition is met. Now, here, a hint is that you can keep track of variable I on a scrap piece of paper. You have another new command called turn left. This command turns the robot to the left 90 degrees. Click to see a new pattern, or to see a new program. You don't have to click to see a new program, it's right here. Run the program on your board. Where will the robot end up? So if we go here, got your little thing here, 3 is not less than 3, you're going to exit the loop at that point. So go ahead and pause the video and try running this one. Okay, ready to try this together? I is set to 0. We're going to go through the loop. So we're going to move forward, turn right. So we'll move forward. Then we're going to turn right. Then we're going to move forward. And we're going to turn left. Okay. Then we're going to come up here and we've got I plus plus. So now I is 1. We're going to move forward. Oops. So move forward, and then we turn right. Then we're going to move forward. We're going to turn left. Ready? Then we come through here, and I plus plus, I becomes 2. And we're going to do it again. We're going to come through, and we're going to move forward. Then we're going to turn right, and then we're going to move forward, and then we're going to turn left. And now I gets incremented to 3. I is not less, 3 is not less than 3, so we stop. So we are in this square pointing up. Were you successful? I hope so. All right, pause the video and try this one. Ready to try it? Okay, when I is 0, we're going to move forward, turn right, and move forward. Then I becomes 1. And then we're going to go forward twice. So 1, 2, and then we're going to turn right, which means now we're going to be facing down. And then we're going to move forward. Then I is going to become 2. 2 is less than or equal to 2, so we're going to continue. We've got to move forward twice. So we move forward once, we move forward twice, then we're going to turn right, and then after we turn right, we're going to move forward again, and then I is going to become 3. 3 is not less than or equal to 2, so we exit the loop. And here is our ending position and our ending orientation. Try this one. Okay, here's a program. Try going through it and see if you wind up in the right location. Okay, we're going to move forward once. Then we're going to turn left. So I need my left one. And then I'm going to turn left again, which is going to point me down. Then I'm going to move forward twice. Now I is going to become 1, and I'm going to do this all again. So the first thing I have to do is move forward once. Then I'm going to turn, oops, come down here so you can see, turn left. So if I'm facing down, turning left is going to cause me to go, oops, come on, this direction. And then another left will cause me to be up. And then I'm going to move forward twice. 1, 2. And notice that I wind up right back where I was started. And now I becomes 2, but I is not, 2 is not less than 2. So therefore, I jump out of my loop. Now, let's make it a little more challenging. We're going to ask, can we move to the left or can we move to the right? We're going to add barriers and we're going to recognize the wall. So can move left, can move right, can move forward, can move backward. These evaluate to true or false, and they're dependent on the direction that the robot is facing. If a barrier or wall is in the way, the Boolean expression evaluates to false. So, if we take a look here, can move forward? Yep. Can move right? Yep. Can move left? No. Can move backward. True. Doesn't mean that you're moving. It just says, can I? Here's another example. I can move forward. I can move to the right. I cannot move left. I cannot move back. Left hits a wall. Back hits a barrier. So now try this program. You've got two barriers, and of course you've got the walls. So I is set to 0. Great. I can run through the loop. If I can move right, can I move right? Yes, I can. So if I can move right, then I'm going to turn right and move forward. That ends the if. Then I'm going to turn left. Okay? So I'm going to turn left. If I can move forward, then I'm going to move forward, but I can't. So I just jump out. Now I becomes 1, and 1 is less than 3. Can I move to the right? Yes. So I'm going to turn to the right, and then I'm going to move forward. Then I'm going to turn left. Now, if I can move forward, I'm going to move forward. I can move forward, so I will move forward. Then I will become 2. 2 is less than 3. If I can move forward, can I? Yes. Or sorry, if I can move right, I cannot. I have a wall here, so I cannot move right. So I'm going to jump down here, and it says turn left. So I will turn left. Can I move forward? Nope. So I'll just jump out, and now becomes 3. 3 is not less than 3, so I jump out of my loop. Try this program. Trace through it, and notice I put where you should be ending up in round 1, 2, and 3. All right, so the very first one, I works. So can I move forward? Yes. So I'm going to move forward. Then I simply turn left. Then can I move forward? Yes. And so I do. And then no matter what, I turn right. Now, I is incremented to be 1. If I can move forward, I move forward. Turn left. If I can move forward, I can't, so I turn right. Now I becomes 2. If I can move forward, yes, I can. So I will move forward. Then I'm going to turn left. If I can move forward, I can. So I will move forward. Then no matter what, I'm down here and I'm going to turn right, which will put me back this way. And then I'm going to be at the end of my loop. So I increment 2 to 3. 3 is less than 4. Can I move forward? No. Turn left. Okie dokie. Can I move forward? So I will move forward. And then I turn right. And then I'm done with the loop. And I increment I, and I'm at 4. Is 4 less than 4? No. So I'm going to exit the loop. And this is my final location and my final orientation. Okay. Here's a challenge. If we're in class, I would tell you to set up a game board, add as many barriers as you'd like, and write a program using a for loop to navigate the board. Figure out the starting and ending points of the robot. Share your board and code with another group or another person and see if you agree on the ending point of the robot. Remember that I can be less than any number. You could keep this going. You could do it 10, 20, 30 times. It gets a little crazy the more you do it, but you could. Since we're doing this virtually, we'll skip this challenge part. Now, At this point, we're going to watch a video with Jerome, who is an engineer at Microsoft, and he's going to go through and talk about loops. So, if you're watching this at home, please pause this video or just finish up this video and then go and watch this video, accessible either from Unit 5, Lesson 5 in code.org or Unit 5, Lesson 5 in Canvas. Either one. Now, as a wrap-up, iteration is a repetitive portion of an algorithm which repeats a specified number of times or until a given condition is met. An infinite loop occurs when the ending condition will never evaluate to true, so you get stuck inside. Now, next lesson we are on to investigating loops.